This is virtual prototyping with Crucible, running real Linux software, and a machine learning workload on a custom accelerator, on a chip that hasn't been fabricated yet. No RTL, no physical board. The entire system-on-chip CPU memory, a custom accelerator IP, exists only as a virtual model, and everything you're about to see runs on top of it. Let's set up the environment. Kick things off by invoking Crucible with igny init inside the project folder. Spin up a fresh environment with igny env create, giving it a name you'll recognize later. The CLI confirms the environment is ready on the default stack. Create a workspace pointing at the demos folder and bind it to the environment you just made. Once the workspace is registered, hop into that directory so the next commands run in the right spot. That wraps up the workspace setup. Let us go to the next step, which is to install tools and compilers. Pull in Renode with igny tool install Renode since you'll need it to emulate the RISC-V board. The tool lands cleanly and gets bound to your environment. Check which compilers are available by running igny compiler list. You get a full table of targets, showing which ones are installed and the binaries each one provides. Grab the RISC-V bare metal toolchain by installing RISC-V non-elf GCC so you can build the firmware. The compiler installs and locks onto your environment automatically. The toolchain is in place and ready to use. Let us go to the next step, which is to review the source and model files. Open nefnest classify.c to see the C code that runs the inference on the emulated core. Then jump into mnist model dh, where the quantized model, int8 weights, biases, and test images for the FC784-6410 network compiled straight into the target binary. Peek at the Renode script too, since this is what wires up the LiteX VexRiscv machine for the simulation. That covers the files driving the demo. Let us go to the next step, which is to launch the Renode simulation. Back in the terminal, move into the LiteX VexRiscv accelerator directory where the run script sits. Fire up Renode through igny run, pointing it at the RISC script with the console attached and logs hidden. A UART window pops up and you can watch the build root kernel come online right through to the login prompt. Login as root and the welcome banner from the demo image shows up. The virtual machine is up and waiting for you. List the files in the home directory to confirm the demo binaries got baked into the rootfs. Run the hello world ignition binary first as a quick sanity check that user space is working. Kick off manist chart classify and watch it render each digit in ASCII, predict the label, and finish with a 100% accuracy score. The ML workload is running end-to-end on the emulated core. Let us go to the next step, which is to exit the simulation session. Head back to the VS Code terminal and send quit to the Renode monitor to shut the emulation down. Wrap up the ignition session with igny exit so the environment unbinds cleanly. One last clear and you're back to a fresh prompt, ready for the next build. That's virtual prototyping end-to-end with Crucible. From igny init to a working ML workload on custom accelerator hardware that doesn't physically exist. The entire environment is reproducible, down to the exact tool versions, so this same prototype runs identically on any machine. Try it on your own system on chip design and start validating software before the chip does.